Hello everyone, it's Dmitry Anoshin and Surfalytics. This is still Model 1. This is one lesson that I wanted to create for a very long time, and I just myself personally very interesting to learn more about history of approaches, of like some fundamental knowledge, where it's coming from. So hopefully I collected some bits of this information and I can share with you. So I tried to cover around like 30 years of analytics, data engineering. Back in the time, there wasn't any word like analytics. Maybe analytics exists, but data engineering definitely not. There was just databases, there were custom applications, and so on. So the goal is to trying to go through like 30 years of experience, not mine experience, overall experience in the industry, and see like some bits and some examples what exists in the past, what exists now, and what we can expect in the future with the rise of generative AI and large language models. By the way, don't forget to like the video, don't forget to share, leave comment. So in the overall idea, there is the course, the free course, getting starting with analytics and data engineering there. I want to cover as much as I can, as much as I know. And for some people who are very interesting to leverage their career, to bring it to the next level, to get competitive advantage, they can subscribe to Surfalytics memberships, where we do the projects, we run mock interviews, the coding interviews, practicing the questions for interview, know the salary ranges. So you will cover from all points for your successful career. Okay, let's get started. Probably you saw this slide in one of the videos, but just in case I want to repeat it, because for me to explain what is analytics is quite simple. So this picture, analytics value chain, is explaining it really well. Because every organization, and here I mostly talk about profit organization, because for us, if we're curious about building our career to get the solid compensations, we definitely have to focus on profit organizations. Non-profit organization is very nice. If you have free time, you can build the pet projects, you can leverage your skills and do something good. For example, I participate in different non-profit organizations where I can apply my data engineering skills, my knowledge, and just help to leverage the data. But to live good life, to raise the kids, to buy expensive gifts to our loved one, to our parents, we need the good compensation. That's why we will focus on the profit organizations. And overall in Surfalytics, there are so many different tips that can help you to get the job almost everywhere in the world related to the data analytics and data engineering. Let's talk about organizations. Why they exist? They exist to generate the value. And this value could be different. There are different groups of people, usually with stakeholders, with customers, employees as well. So they need different kind of value. Customers really care about the product quality, their customer experience. The stakeholders usually care about their profit, the revenue, some different kind of metrics. Employees, they care about work-life balance. They want to get their bonus on time. They want to have the job security by the end of the day. For organization to continue to exist and grow, it has to generate more value. And the trick is, if any organization wants to generate more value, they need to make decisions. They need to make decisions almost every day. And recently I watched one of the YouTube video, I forgot the name, but there was a really nice term about that organizations, it's basically fabric of decisions, right? So it should be conveyor of decisions, and decisions should be good. They should be good that they help to increase the value, improve the product quality, improve overall life of all groups involved in organizations. Since we're talking about the data, obviously you need to get the data, right? And you need to use the data to make the decisions. My course and my experience, and probably your experience, will be related in 99% is to working with the data, extract the value, and help people, business leaders, to make the decisions. It's very simple. It's the same as you can imagine. You have some financial transactions in your bank account and you need to make decisions. Are you ready to go with the family to vacation, or you're not able to afford this, right? You can look to what's your spending, what's your expenses, do you expect any bonuses, and so on and so on. And you can make decisions like, does it work for you to go with vacation with family? Oh, it's not right time. The same organizations, but they have not just financial information. They have like the product logs, the telemetry, customer reviews. They have lots of digital marketing, social media information, many different information. The thing is, we need to combine this information together. And in the lesson like 1, 2, 3 on the model 1, the same model, I talk about organization. Like we look on example of organization, for example, just e-commerce who's selling t-shirts. By the way, I'm still thinking to create the t-shirt shops for Surfalytics. And I have really cool ideas for t-shirts. And also I'm thinking about that if I will create this shop, I can use this data to actually create real-time projects for Surfalytics students to use real-time data and real data from real business, that they can apply their knowledge to actually build not just pet projects in Wacom, but actually build the solution for the business and see how their decisions can help to improve the business, or maybe just to build nice solution and explore different technologies. It was really long introduction about analytics. As you know, or maybe not know, my focus is really about the value. My focus is about you as a person who's going to work with the data, already work with the data. You not just work with the tools, you're not writing the SQL, Python, like building dashboards, you actually create the value. So you should think about yourself is how you're going to add the value to the organization, how you're going to add value to the hiring manager. That's why for all Surfalytics members, over and over, for every mock interviews, for every conversation I have with the students, I trying to bring their attention, not the tools we're going to use, not the language we're going to use, but actually how you can add the value. Because you can use the Python, you can use SQL, you can use Microsoft spreadsheets, Microsoft Excel spreadsheets to work with the data. But your end goal is to generate the value for the organizations. And decisions is the product of our work with the data. And the good decisions that can help impact the organization, that help to increase the revenue. Sorry for a very long introduction, but it's important. It's important, and don't forget to mention all those things about how you're going to add the value, how you can cover the pain points for typical organizations, how you can help to solve the data problems in the organization. The goal analytics, cover it many times, increase the revenue, decrease the cost, mitigate the risk, explore markets and products, validate hypotheses. So it should be obvious and clear for everyone. The list can be really long, depends on the industry, depends on the product. We all can wrap it as a value, but here we can more like quantify the value. The key milestone that I'm going to cover, they really intersect with my career, because my career path started like around 2010. It is right here where we have enterprise data warehouse, enterprise BI tools, and so on and so on. But before this, there was some more straightforward approach to work with the data using relation database. But in this presentation, I even found some insights about what was before, and it's really cool to know and see. This is the current state as for 2024 about data engineering tools. And it doesn't really matter what those logos represents and what the particular column they. The thing is, there are so many logos, so many things, and we can think about this from different perspective. There are so many organizations and startups who building the products for the data. Most of them, I'm not talking about like Snowflake, Databricks that are already pretty mature and popular, but I will talk about smaller startups. They have VC funds, money. They use this money to hire the marketing people, the product people, who will write really nice things about the product, and basically they will offer you the silver bullet to solve most of your data organization problems. As a result, the biggest challenge for you as a person who wants to gain skills, who wants to get the good job, you don't know where to start, you don't know what to learn, because all tools, then you read them, they really means similar things. You work with the data, you apply the value, it's like revenue grow, just use our product. Like, it's not true. That's why in Surfalytics, I don't want to focus a lot on the vendors. I really want to focus on fundamental knowledge. For example, If we know how to wrangle the data in spreadsheet, we probably can wrangle the data in BI tool. Or if we know how to build the dashboard in Tableau, I bet we can do the same dashboard in Power BI, in Looker, in Sigma, Metabase, anything. Because the principle they're the same. So that's why don't really worry about the vendors. Worry about the principles that you're going to use to work with data, how you apply your skills, and how you're going to solve the problems, the data problems. If you know like 5-10 data problems, you can share during the interview how you did solve, even if you never solved them. It doesn't matter. But you need to clearly understanding the problems, the solutions, and use like several tools that can help you to solve. During the course of Surfalytics course that's free, I will cover many different tools, and I will also highlight some other tools because different point of time, there are some tools more popular, some tools less popular, and it's very interesting to see how the industry is changed. For example, right now is very popular Lakehouse. But what is Lakehouse? If we look closer to Lakehouse, it's actually like similar to data lake, where some data format is changed, how we're storing the data, but in terms of querying patterns, they're still the same, and so on and so on. During this presentation, I will try to cover this. This is another one. It's machine learning in data landscape. It has not only data engineering, data analytics tools, it's also some machine learning things, but I'm following this chart for a very long time, and it's just growing, enormously growing. And right now, because I have friends who work in VC, I just see how they starting investing in data tools. And it's just a sign maybe the market is back, because currently the economic situation is not good. It was a very hard time for the last couple of years to raise the money for startups, but now it looks like the money is there and they're investing in those startups. So what it means for us, we have more marketing, more buzzwords, and it will again like more tools coming to the market, and it will be harder for us to choose the best solution for our organization. Okay, let's try to quickly cover what was before Business Intelligence Data Warehouse and ETL as we know today. The first thing I found is data tabulation and automation. You can see there is the Wood machine. Herman Hollerith invented the tabulating machine in 1980s to efficiently tabulate and process census data. This is one of the examples. Let's move next. So there is, honestly, I put 1980s here. We need to double check it. And while I will edit the video, I will just double check it's 1980s. I put some comment because mainframe looks more modern, but the year is younger. So mainframe years looks okay for me. So this is just example of mainframe. This is how the organizations, big organizations, use computer in the past. So then we should mention about Edgar F. Codd, who invented relational database. So probably everyone aware about SQL or SQL. I don't know what's the right. For example, I started to use SQL after I watched one of the free courses from Stanford or Cambridge University or Stanford University on EDX platform. And this course, they use word SQL. I just said, okay, let's do SQL too. But you can use SQL or SQL up to you. So, and Edgar F. Codd basically invented a relational database. Then we should mention about key persons in the industry, Bill Inman and Ralph Kimball. So Ralph Kimball invented dimensional modeling, and he has the book, The Data Warehouse Toolkit. The Bill Inman write also, they both like father of data warehouse. They still alive and they still very popular. I mean, their approach very popular. We also can add like Data Vault and then Lindstedt, who invented the Data Vault. I think nowadays most people work with dimensional modeling, and most introduce about dimensional modeling theory. So just learn a couple definitions, what is it, and yeah, those books, they're quite big, they're quite challenging. My honest feedback about those books, they're great. They're covering everything really nice, but it's really hard to learn new skill without hands-on experience. I think if someone will create GitHub repo for this book with all the code and the data sets that you can apply to the book, then it will be tremendously helpful for everyone. And maybe Surfalytics should build one. I don't know. That's a good idea. So then I found the spreadsheet program, VisiCalc, that was available in 1970s, right? You see, so it means the Microsoft Excel, it wasn't the only technology that was built by Bill Gates and Microsoft. There was something before already built, just we'd never seen this. We should mention ANSYS SQL, right? In 1986, I saw an ANSYS standardized SQL to create common language that all databases could understand. Obviously, before standardizations, if there is like SQL code, and different database can have like different SQL code that not really works with each other. So if you have, after standardizations, there are certain rules that apply on all databases. And for example, if you build new database engine, you don't need to invent bicycle, how you're gonna query your data from the tables. You can just use the standard. And it means that if anyone will use your products, they don't need to learn anything specific. It's very, very similar like everyone else. That's why for myself, I really don't care what kind of relation database I work. I know that they're all the same. So I will just connect the database using JDBC or DBC drivers, and we will use this type of connections among all cores for anything to connect our databases from clients, from BI tools, ETL tools, and so on. And I just will start querying the data. So this is another example of graphical user interface in 1980s. You can see there is actual line chart and the pie chart, so how it looked like in the past. So now we can move to the next topic about enterprise BI and data warehouse. My first product that I worked with data warehouse world was Oracle. Then I was hired by BI developer, working with SAP Business Object. Still love this product, but probably used it last time in 2013, like almost 10 years ago. And I work with Oracle database. We use it as a data warehouse, obviously running on-premise. On-premise means it's a data center in an organization and Oracle installed there. Then I joined Teradata. Teradata was the main competitor of the Oracle. It's one of the probably best companies that time. They started in 1979, yeah, and then they come up with the data warehouse product because they also built the databases for transactional database. Then they started build the analytical data warehousing. Teradata was the main competitor of the Oracle, but architecture of the data warehouse was very different. They came up with maybe before it was already existed, but their architecture, sharing nothing, or it's all similar to distributed computing. So you have multiple servers that have independent resources like CPU, hard drive, memory. They can query data only that they own. And also data replicate among other machines. If one machine machine or node go out, another machine will work. So the Teradata, probably for me at least, it's one of the best product that time, one of the best data warehouse product. And yeah, unfortunately, right now they not in good shape since Snowflake rised and AWS rising, and first is Redshift, then Snowflake, BigQuery, all those products in the cloud, they basically wipe out Teradata. But Teradata is still available because another challenge, if most of S&P 500 customers running those legacy platform like Teradata, they have data centers, they have physical hardware, and they have huge implementation. It's extremely expensive and difficult to migrate off. That's why they continue to pay license fee, support fee to Teradata. But of course, for all new initiatives, they probably move to the cloud. And Teradata also offering cloud, the Oracle offering the cloud is probably not that great as AWS, Azure, and GCP. There is public cloud available for everyone, and they're using in most organizations. And by the way, you have to know cloud computing, like one of the vendors among three, AWS, Azure, and GCP. In my course, I will cover it because I'm teaching for the last 4 years. I'm teaching cloud computing in Canadian University of Victoria. I will have dedicated model for the cloud computing, and we'll learn Azure and AWS and maybe a bit of GCP. But coming to here, I also will talk more about data warehouse architectures, sharing nothing, sharing everything, SMP, MPP on the model 6 of my course. Then we'll start working with different data warehouses. So it means like right now we're on the model 1, and we only will start learning those analytical data warehouse on the model 6. It means to actually become data engineer or better analytics engineer or just an engineer, we need to cover lots of materials that we're going to cover. Another topic here is enterprise ETL. One of the most popular product was Informatica. So it came up in 1993. Alternative is ELT. So ETL stands for extract, you extract the data, then transform and load. And the challenge was here for Informatica. So again, it's everything on premise. And if you're running Informatica and you have pretty big data warehouse, could be Oracle, IBM, even SAP, like any kind of the big enterprise vendor. You have, for example, expensive, huge data warehouse. The ETL means the transformation happening on ETL product. Like in our example, it's Informatica should process all the data. If you're loading every day like 100, I don't think like 1993, even 2000, we had like 100 gigabytes a day process, but maybe it's who knows. So, but the idea here that this tool should process all the data that loading into data warehouse. Even if we do full reload of the data or backfill, it means that our tool should process everything. It means that the cost for hardware for ETL tool almost the same as a hardware for data warehouse, because it should process the same amount of data. You don't need to store like historical data, but whatever you process, ETL tools is process and read everything, and then maybe in most of the cases just insert row by row in our data warehouse. That's why that time, even like in 2000s, there was the term like bulk load, how you can outsource the transformations to analytical data warehouse. For example, then we use Teradata in Big Bang. We trying to leverage analytical capabilities of Teradata, of this distributed computing, and we use Informatica more like orchestration. And this is what currently happening with the cloud. So we usually don't use the tools that will transform data inside. The tool will issue commands to, as soon as you push the data to the cloud data warehouse, it will process in data warehouse using computing of data warehouse. Yeah, we'll learn how it works. We'll do lots of hands-on, but in the future. And we're already doing this in our pet projects in Surfalytics. And the enterprise BI. The third category, obviously like business objects, MicroStrategy, Oracle BI. So all those products is quite popular. MicroStrategy is still on the market, but I think they really huge invest in Bitcoin. So I don't know, they like crypto company or BI company. They have the same story as a Teradata. Lots of legacy companies who are running on MicroStrategy, and I assume they still running MicroStrategy on top of Teradata, Oracle, and hosted on premise. The one nice things about those tools in comparison with the modern tools. So, and this is, for example, the screenshot I have about history of business objects. So how it was rising, and then they come up with web intelligence tool for like the first time ever you can do your web browser things. And there was business objects, and then acquired the crystal wrappers, then SAP acquired business object. And usually after all big acquisitions, it's starting sunset of the product. So we saw this with business object. Recently, we saw how Google acquired the Looker and how Salesforce acquired Tableau. So those products definitely lost their shine. They're still good products, but not that good how they were when they were completely independent. But anyway, business objects, I think all those tools, they have one thing in share. They had semantic layer. They had semantic layer, and probably the closest nowadays is the Looker. With the Looker model, you have the one huge semantic model of all your tables, like basic abstraction of tables in data warehouse. They are joins, and then you can build your visualizations, your self-service workbooks, explorers, whatever you want. I used to work as a BI developer for almost like 4 years, working with SAP Business Objects, working with MicroStrategy, starting to learn Power BI, Tableau, Looker, all those tools. So I probably still very good with BI tools, and I believe to be as a good BI developer, you should know at least one tool really well. You should know SQL well, and you need to know how to administer the BI tool. It's hardware, the software, all the updates and patches, and also how you manage the users. Yeah, that's it. The goal of BI tool, it's a kind of like, it's window for the business users to work with data, because the data in the business application, data warehouse is not user-friendly. That's why I always thought that BI tool is a kind of like translator from your data warehouse, like tables, column names that are unfriendly, to really friendly user interface where you have dimensions and measures and the user can do drag and drop. So it's still happening nowadays. As you might guess, the problem not in the quality of software, not the quality of the vendor, but how the data is accurate, what's the quality of the data, and can users trust the data? Can they make decisions? Because it's very easy to make mistake in your data pipeline, in your transformation, or just the bad data coming, like bad data in, bad data out. The fundamentally, even like probably for the last 20 years, all the same. We just use different stack. We started working in the cloud. We're using more like nice visualization. It's faster. It can process bigger data. Because it's faster and bigger data, you just can fail way faster. And probably to find your error, mistake, like root cause, will take longer. So the data mining is another term. Now, right now is the data science, but idea with the data mining that there were like different statistical package that can help you to apply the math, apply the skills of like your, real research scientist. If you have research scientist background and you want not just look like historical on the data, but you actually want to do any kind of deep dive, searching for the pattern, the hidden pattern, or maybe you want to do some kind of forecast. This is data mining. Right now, this term is data science or machine learning engineers who apply different machine learning algorithms. In the past, it's just data mining, because decision trees, logistic regression, not just regression, clustering, all those things existed for a very, very long time. Probably the most popular product that I was aware, it was IBM SPSS or SPSS Modeler that was acquired by IBM. And yeah, nowadays it's very different. Everyone using different Python packages and running tools hosted in the cloud and so on and so on.